Hi students. Okay, today here in the lecture we discussing the topic is half range Fourier series. So already we discussing in the discussed the previous lecture, that is the Fourier series expansion of the given function in the interval minus L comma L 0 comma 2L 0 comma 2 pi minus 5 comma 5. Okay na? So that is complete full interval. So now we are finding half range Fourier series, that is of interval of the given four intervals, that is equal to 0 comma L and 0 comma 5, two positive half range interval 0 comma L and 0 comma 5. In two intervals we are to finding half range Fourier series expansion of the given function. Okay, first of all see that this is half range only two types of series. The first one is Fourier sine series and Fourier cosine series. In both series expansion in two intervals, that is 0 comma L and 0 comma 5. So first of all see the definitions of Fourier sine series and cosine series. What is the meaning of Fourier sine series? The series contains only sine terms. So how to finding sine terms here only? Automatically a0, an zeros. So similarly to find Fourier cosine series. So cosine series means the series contains only cosine terms, that is automatically bn 0. A0, an finding bn 0, that is cosine series. Okay, first of all see the formulas. So first half range Fourier sine series in the interval 0 comma L and 0 comma 5. Okay, Fourier sine series of f of x in the interval 0 comma L is f of x is equal to summation n is equal to 1 to infinite bn into sine n pi x by L, where bn is equal to 2 by L into integration 0 to L f of x into sine n pi x by L dx. And that means this is a already we find out, that is only Fourier series expansion for odd function in the interval minus L comma L. Okay, now that is this is the same only. So that is odd function minus L comma L. This is a sine series in the 0 comma L interval only. So similarly in the interval 0 comma 5. So in the interval 0 comma 5 is the series is similarly same L place lo pi replace chain in the above formula. That is equal to f of x is equal to summation n is equal to 1 to infinite bn into sine nx, where bn is equal to 2 by 5 into integration 0 to pi f of x into sine nx into dx. So this is a half range Fourier sine series. Okay, similarly we define half range Fourier cosine series. Okay, so half range Fourier cosine series in the interval 0 comma L and 0 comma 5. So in the interval 0 comma L is given by f of x is equal to a0 by 2 plus summation n is equal to 1 to infinite an into cos n by x by L. So ikkada bn 0 and only cosine series ki finding a0 an, where a0 is equal to 2 by L integration 0 to L f of x dx. an is equal to 2 by L into integration 0 to L f of x into cos n pi x by L into dx. Similarly in the interval 0 comma 5, L plus lo 5 replace chain in the above formula, that is equal to here in the interval so that is Fourier cosine series of f of x in the interval 0 comma 5 is f of x is equal to a0 by 2 plus summation n is equal to 1 to infinite an into cos nx, where a0 is equal to 2 by 5 integration 0 to pi f of x into dx. an is equal to 2 by 5 into integration 0 to pi f of x into cos nx into dx. So this is a half range Fourier cosine series. Okay, see the problems here. The first problem, find Fourier sine and cosine series of f of x is equal to 2x in the interval 0 comma 5. So that is half range Fourier sine series and cosine series of the given function. So here given interval 0 comma 5, that is equal, first of all finding half range Fourier sine series. So that is equal to formula in the interval 0 comma 5, f of x is equal to summation n is equal to 1 to infinite bn into sin nx, where bn is equal to 2 by 5 into integration 0 to pi f of x into sin nx into dx. So now finding bn is equal to 2 by 5 integration 0 to pi f of x place load 2x here, given function 2x into sin nx into dx. So bypass method, u into v method. So 2 common, 4 by 5, get x into sin x, no? U into v, x into integration of v, integration of sin x minus cos nx by n minus, so x derivative 1. Again 1 is a constant, derivative of sin 2 times minus sin nx by n square, limit 0 to pi. Substituting here 4 by 5, first upper limit x is equal to pi minus 5 into cos n pi by n, so plus sin n pi 0, lower limit 0, x is equal to 0 kada 0, next sin 0 0. Simplification is minus 4 by n into minus 1 power n. This is a bn value. Substituting in the equation 1, that is a required half range Fourier sine series, that is equal to 2x is equal to summation n is equal to 1 to infinite minus 4 by n into minus 1 power n into sin nx. So that is a simplification is. So next one, continuation, find half range Fourier cosine series. Okay. So half range Fourier cosine series of f of x in the interval 0 comma 5 is, so f of x is equal to a0 by 2 plus summation n is equal to 1 to infinite an cos nx. First finding a0 is equal to here, and this is an is equal to, okay. So a0 is equal to 2 by 5 into integration 0 to pi f of x dx. So 2 by 5 0 to pi f of x is equal to 2x into dx. So 4 common, okay, 4 by 5 x square by 2, limit 0 to pi, so that is equal to 2 pi. So this is a0 value. An is equal to integration 0 to pi f of x is equal to x into cos nx. So that is equal, bypass method, 4 by 5, 2 common, x into cos nx here, x into integration of cos sin nx by n minus integration derivative of x 1 is a constant, cos ki 2 times integration minus cos nx by n square. Limits apply 0 to pi, 4 by 5, upper limit 5, sin n pi 0, minus to minus plus cos n pi by n square, lower limit 0, sin 0 0, so minus into minus plus into minus, formula minus 1 by cos 0 1 by n square. So that is equal to 4 by 5 n square into minus 1 power n minus 1. This is the an value. Substituting a0 an in equation 2, so there is a required Fourier cosine series is 2x is equal to 5 into summation n is equal to 1 to infinite 4 by 5 n square into minus 1 power n minus 1 into cos nx. So this is the required half range sine and cosine series. Okay, so next question, find Fourier cosine series expansion of the function f of x is equal to x square in the interval 0 comma 1. So 0 comma 1 means 0 comma L interval. So given function x square, find only cosine series. So there is a given function, so 0 comma 1 is equal to 0 comma L is equal to 1 here. So in the interval 0 comma L, half range cosine series is f of x is equal to a0 by 2 plus summation n is equal to 1 to infinite an into cos n pi x by L. A0 is equal to 2 by L integration 0 to L f of x into dx. An is equal to 2 by L into integration 0 to L f of x cos n pi x by L into dx. So first finding a0 value. So a0 is equal to 2 by L integration 0 to L kada. Ante L is equal to 1 in the interval 0 comma 1. So 2 by 1 0 to 1 x square dx, integration of x square x cube by 3, limit 0 to 1. So that is equal to 2 by 3. This is a a0 value 2 by 3 and okay, next one's finding an. So an is equal to 2 by L integration 0 to L f of x into cos n pi x by L into dx, that is equal to 2 by 1 integration 0 to 1 x square into cos n pi x into dx. So here u into v method, this is a u, this is a v. So 2 into x square into cos integration sin n pi x by n pi, limit 0 to 1 minus x square derivative 2x. So now integration second time 0 to 1 cos integration sin n pi x by n pi. So that is equal to, we are substituting upper limit sin x is equal to 1 sin n pi 0 sin 0 0. Next here common 2 by n pi is a constant, is a common, minus 2 by 5. Again u method, x into sin n pi x, u into v. So x into integration of sin minus cos n pi x by n pi minus derivative of x 1. Again 1 is a constant, 2 time integration of sin minus sin n pi x by n square pi square. Now substituting the limits, ఇక్కడ 2 into minus 2 by n pi అంటే minus 4 by n pi. ఇక్కడ upper limit x is equal to 1 minus cos n pi by n pi plus this sin n pi 0. Next lower limit x is equal to 0 అంటే 0, next sin 0 0. That is equal, simplification is 4 by n square pi square into minus 1 power n. This is the an value. Substituting a0 an in equation 1, the required Fourier cosine series of f of x is x square is equal to 1 by 3 plus 4 by 5 square summation n is equal to 1 to infinite 1 by n square into minus 1 power n into cos n pi x. This is the required Fourier cosine series. Okay, so next one, next question, find Fourier cosine series of f of x. So x in the interval 0 comma 1, 2 minus x in the interval 1 comma 2. So given interval is 0 comma 2, the 0 comma 2 is 0 comma L, and also deduce that. So now we have to show that this condition. Okay, so first we have to finding sine series. Fourier sine series of f of x in the interval 0 comma L is f of x is equal to summation n is equal to 1 to infinite bn into sin n pi x by L. Bn is equal to 2 by L into integration 0 to L f of x into sin n pi x by L into dx. So given function is depend two cases here, breaking point 1 and integration is also separating 2 times. L is equal to 2. So 2 by 2 integration 0 to 2 f of x into sin n pi x by 2 into dx. So integration is also separate, integration 0 to 1 f of x is equal to x into sin n pi x by 2 into dx plus integration 1 to 2 f of x is equal to 2 minus x into sin n pi x by 2. So now bypass method, so x into sin n pi x by 2 kada, u into v method, x into integration of sin minus cos n pi x by 2 in by n pi by 2. So derivative of x into 1. So 1 constant sin 2 time integration minus sin n pi x by 2 by n square pi square by 4, limit 0 to 1. So here again bypass method, u into v. So 2 minus x into integration of sin minus cos n pi x by 2 by n pi by 2. So integration derivative of 2 minus x into minus 1. The minus 1 is a constant, sin ki 2 time integration minus sin n pi x by 2 by n square pi square by 4, limits 1 to 2. Substituting the limits, the first one, so x is equal to 1, x is equal to 1, 2 by n pi kada, take the reverse, minus 2 by n pi, x is equal to 1 cos n pi by 2. Next sin n pi x by 2 kada, అంటే sin n pi by 2, x is equal to 1 కదా, అక్కడ minus to minus plus 4 by n square pi square into sin n pi by 2. Next lower limit 0, ఇక్కడ x is equal to 0 0, next sin 0 0. Next second term x is equal to 2 కదా, అంటే 2 minus 2 2 minus 2 is 0. Next one, x is equal to కదా, x is equal to అంటే sin n pi, 2 cancel, sin n pi is equal to 0. Next lower limit 1, 1 అంటే 2 minus 1 1, ఇక్కడ minus of minus plus 2 by n pi into cos n pi by 2. Next one here minus to minus plus, minus to minus plus, formula minus. So x is equal to 1, 4 by n square pi square into sin n pi by 2. So for simplification is, so here cos terms cancel, so cos term is a cancel, remaining 4 by n square pi square into 8 by n square pi square into sin n pi by 2. So this is the bn value. So bn substituting in equation 1. So continue the here. Fourier sine series of f of x is equal, substituting the bn value, that is summation n is equal to 1 to infinity 8 by n square pi square sin n pi by 2 into sin n pi x by 2. So put x is equal 1 here. Put x is equal 1. F of 1 is equal to summation n is equal to 1 to infinite 8 by n square pi square into sin n pi by 2 into sin n pi by 2, and x is equal 1 again. Since given function f of x is continuous at x is equal to 1, because left hand continuity and right hand continuity both are same and left continuity is 1, right continuity is also 1, both are equal. So that is equal to continuous. Then we have f of 1 is equal to 1. That is equal to here f of 1 is equal to 1. Substitute here, expand here series. 1 is equal to here n is equal to 1. So 8 by 5 square is a common term. This is a common 1 by 1 1 plus n is equal to 2. N is equal to అంటే 0 అయిపోతుంది. Next n is equal 3 sin 3 pi by 2 into sin 3 pi by 2. So that is equal to 1 కదా. So 1 by 3 square plus n is equal to 4. N is equal to 4 అంటే sin 2 pi అంటే 0. Next n is equal to 5. ఇక్కడ minus 1 into minus 1 plus 1 by 5 square plus up to so on. So right outside 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so on is equal to pi square by 8. This is the required result. Yeah, next question. Find half range Fourier sine series of f of x is equal to cos x in the interval 0 less than x less than pi. That is equal, given function f of x is equal to cos x. So in the interval 0 comma 5 is the Fourier sine series. So that is equal to f of x is equal to summation n is equal to 1 to infinite bn into sin nx, where bn is equal to here. Finding bn is equal to 2 by 5 integration 0 to pi f of x is equal to cos x into sin nx dx. So that is equal to 1 by 5 into 2 inside of the integration, which is can be read 2 sin nx cos x. చూడండి 2 sin a cos b form అండి. 2 sin a cos b form 1 by 5 into integration 0 to pi sin a plus b plus sin a minus b అండి. ఇది ఫార్ములా 2 sin a cos b form sin a plus b అంటే ఇక్కడ n plus 1 into x plus sin a minus b n minus 1 into x dx. Now finding the integration. So 1 by 5 into integration of sin minus cos of n plus 1 x by x coefficient into n plus 1 sin integration minus cos minus of n minus 1 x by n minus 1 limit 0 to 5. First substituting upper limit 5 kada, 1 by 5 into minus cos of n plus 1 5 by n plus 1 minus here cos of n minus 1 pi by n minus 1 plus lower limit x is equal 0 అంటే cos 0 1 minus of minus plus 1 by n plus 1, next to minus of minus plus 1 cos 0 1 1 by n minus 1. So now simplification continuation. So that is equal to 1 by 5 into, so cos n plus 1 pi కదా, ఎక్స్పాండ్ చేయండి. 1 plus 1 అంటే cos n pi cos pi అంటే minus 1 power n into minus 1 కదా. So that is equal to cos pi sin n pi sin pi 0 కదా, అవునా. సో ఇయర్ మైనస్ ఆఫ్ మైనస్ ప్లస్ అవుతుంది. cos n pi అంటే minus 1 power n ప్లస్ sin n pi అంటే 0 by n plus 1. Similarly cos a minus b form expanded. Cos minus 1 power n కదా, cos n pi cos pi అంటే minus 1 minus plus plus sin n pi అంటే 0 by n minus 1 plus 1 by n plus 1 plus 1 by n minus 1. Now simplification, take the LCM. 1 by 5 into take the LCM, n square minus 1. So that is equal n into minus 1 power n minus 1 power n plus n into minus 1 power n plus minus 1 power n plus n minus 1 plus n plus 1. Now simplification is 2n. ఇక్కడ n here 1 cancel. ఇక్కడ n both are same కదా, 2n into minus 1 power n. So this is also cancel. Minus 1 power n is a cancel. So 2n into minus 1 power n plus n plus n 2n by n square minus 1. So that is equal to here simplification, 2n common, 2n by pi into n square minus 1 into minus 1 power n plus 1, where n is not equal 0 must be. Okay, so this is a bn. Substituting in the series, so the required Fourier sine series of the given function cos x is equal to summation n is equal to 2 to infinite 2n by pi into n square minus 1 into minus 1 power n plus 1 into sin nx. Okay, yeah, this is a half range Fourier series, that is a finding sine series and cosine series in the two interval 0, L and 0, 5. For more videos, please do subscribe my channel, like and share it. Thank you.